a second code here, PCA, calculate PCA here. So this is the code here. PCA is equal to PCA and component 1, keep one principal component here. Next is DF PD.data frame, create data frame. VIF data variable is equal to x dot columns here. So this is the VIF after PCA here. Thank you. Hello friends, this is a 10th lecture of our data science using Python series. In this series, I will cover the topic of dimension reduction. So first we understand what is dimension reduction. So you can understand this. What is dimension? Dimension is nothing but it is a number of columns. We can say here it is a number of columns, number of input features, variable or columns present in a given data set is known as dimensionality. And the process to reduce these features is called dimension reduction. Dimension reduction is a way of converting the higher dimension dataset into lesser dimension dataset. Why it is needed? It is needed because when we see the higher dimension dataset, it is difficult and it is typical to understand this dataset. So it is used in speech recognition, signal processing, and noise reduction. Imagine you have a lot of information about something like a long list describing a person, height, weight, favorite food. When there's too much information, it gets hard to understand and see clear patterns. Dimension reduction is about keeping only the most important parts of that information and removing extra stuff to make things simpler. So next is what is multicollinearity. Multicollinearity is a problem that occurs when two or more independent variables in a regression model are highly correlated, meaning they provide overlapping or redundant information. This overlap can create problems because it's like having repetitive information which makes it hard to determine the individual effect of each variable on the dependent variable. For example, in a dataset about people's physical attribute, height and shoe size might be related. Means as a taller pupil often have always larger feet. So if both variables are included in a model, they bring similar information, which can cause issue in estimating their separate impacts. So detecting multicollinearity in Python. So one common way to detect multicollinearity is by calculating the variance inflation factor. For each predictor variable, a variable influence factor value above 5 or something 10 often indicate multicollinearity, signaling that the variable has a high correlation with others. Example scenario, predicting house prices. So in this example, we want to predict the house prices. So imagine we have a data set for predicting house prices with the following predictor variable like house size in square feet, number of bedrooms, number of bathrooms, and garage size in square feet. So our targeted variable is to predict house price, but here we can see that house size and garage size are highly correlated because these are highly correlated because two predictor overlap in the information that provide about the house overall size and value. This correlation means there's multicollinearity between the variable, making it hard to tell which factor is really influencing the house prices. That is a point here. So how can we detect? We can detect first we calculate VIF for each variable, and then if a predictor has a VIF value greater than 5 or 10 depending on the threshold used, it indicates highly multicollinear, meaning this variable is highly correlated with other predictions. This is an example here. This is the Python code of our multicollinear. So I will explain the code using this. This is the code of our multicollinearity sample data, data house size, bedrooms, bathrooms, and garage size. We can create first is data frame here, so we can create pd.data frame the data, print correlation matrix here first. After that we calculate VIF here, so when we run this we will get the output VIF after dropping highly correlated variables. So in this scenario our highly correlated variable. Then our next topic in this video is, so our next topic is PCA, principal component analysis. So what is principal component analysis? When we have too much overlapping information, we can use PCA, principal component analysis. It is a featured extraction process of finding multicollinearity to reduce the dimension. PCA keeps the main parts of the data that are important but removes the overlap to make things simpler. So how PCA work? Firstly, find main component. PCA creates components, new pieces that keep the main pattern from the original data but without the overlay. And next is reduce dimensions. Instead of keeping all the original data, we only keep a few of these components which acts like summarize of the data. So this is the code of our reducing for our PCA work. This is the code here. So I will run the code here. What is the file of this?